In this podcast, we'll look at set notation in drawing and making Venn diagrams. So in class, we'll have a poster on the wall, and you can place your dot sticker in the appropriate location. Do you like black licorice, chocolate, both, or neither? So I'll just make up some data for this example. So in this Venn diagram, this whole thing is called a sample space, and the liking black licorice and liking chocolate, those are the events. So let's say we had 5 kids that just like black licorice, 8 kids that like both, 15 kids that like chocolate not black licorice, and 2 that like neither. So this will be our sample set that we look at to learn set notation vocabulary or review it since we looked at it yesterday. Okay, so one of the words that we looked at was union. Okay, so the union symbol is this one, and it means or. And so you might see it written like this. How about B or C? Okay, so actually I write that here. B or C. And again, here's our numbers. So how many like B or C? So or means one or the other or both. So we're set notation, we use the curly brackets. And we have the 5 that like black licorice, the 8 that like both, and the 15 that like just chocolates. So there's set notation. Okay, so or is the U, and it means one or the other or both, and that's called a union. There's intersect. So intersect is this way, and it means and. So how many like black licorice and chocolate means it needs to like both. And again, if we take a look at this, if I say B and C, it would be the overlap right here. So our set notation would look like this, 8. Okay, so intersect means and. So and means it's one and the other. It has to be both of them, or one or the other or both. And then we looked at complement. So complement, again, we had 5, 8, 15, and 2. So there's many symbols for complement. So we could have like B prime, we could have B with a C, we could have not B, but it means not. How many are not in a certain set? I think the most common one used is this one right here with the prime. And so if I say B prime, how many don't like black licorice? And so that would be the outside here, not in the black licorice circle. And so we would have 15 and 2. So complement not in that set. Okay, example 1, let's call the probability of Tommy scoring no goals any given game is event N. And let's say that that's 20% for him. The probability of Tommy scoring exactly 1 goal is 15%, and we'll call that G. Draw a Venn diagram for this situation. Okay, so here's our sample space. And we have no goals, N. And then exactly 1 goal. So here they're going to be mutually exclusive because you can't score no goals and exactly 1 goal in the same game. So again, this is referred to as mutually exclusive. There's no overlap. And let's write in our probability. So no goals is 20%. All right, so 0.2% chance of no goals, a 0.15% chance of exactly 1 goal. And then in the whole sample space is 100. So to find the outside right here, that he scores more than 1 goal, it would be 100% or 1 minus the 0.2 minus the 0.15. And that leaves 65% here on the outside that he could score more than 1 goal. Explain what the following mean for Tommy's goal situation and find the probabilities. The probability of A and B so that he scores, all right, so we're going to say this is N and G. Okay, so the probability that he scores no goals and 1 goal, so no goals and exactly 1, that would be 0%. How about the next one? What's the probability that he scores no goals or exactly 1? So or means one or the other or both. So here we can add them up. So 0.2 plus 0.13, or 0.15 it was, is 35% chance that he scores no goals or exactly one. So one's and, the overlap, there's no overlap here. If it's mutually exclusive, no overlap. And then if it's or, one or the other or both. So to review, mutually exclusive, and is the overlap, so if there's no overlap, it's 0. And so here, if there's no overlap, the probability of A and the probability of B, so this is and this is or, this would be the probability of A plus the probability of B. If they're not mutually exclusive, if there's overlap, then the probability of A or B would be the probability of A, which is this whole circle, plus the probability of B, which is this whole circle. But look, we've counted this part twice, so then we have to subtract the probability of A and B. So that's A or B, it's everything. So the probability of A plus the probability of B, but then there's overlap, so subtract the middle. Okay, so let's take a look at using probabilities in Venn diagrams. Reviewing from yesterday, then we'll review complements. So Mrs. Bajan asked her class the following questions. How many of you know how to rollerblade? And how many of you know how to ride a bike? She put the results in a Venn diagram to the right to determine the following. The following represent percentages. What should the sample space add up to? Well, if it's percentages in her whole class, it should add up to 1, which stands for 100%. All right, let's find the probability that they know how to bike. So they know how to bike is in the full bike circle, so right here, which would be 0.3 plus 0.2 or 0.5 or 50%. The probability that they know how to rollerblade, which is A, is everything in the A circle, and you add them up and we get 70%. What's the probability of A or B? Means we're going to add up one or the other or both, so we add up 0.4 plus 0.3 plus 0.2, and that's 90%. Oh, that was or. I'm sorry, this is and. Erase. Okay, so this is the and symbol. Let's change colors. Okay, so this is and. So how many know how to do both? And means both, and that would just be 30%. All right, I did or down here, so let's switch colors here. The probability of A or B, so this is or, so this is one or the other or both. This is the one where we add them. 0.4 plus 0.3 plus 0.2, and that's 90%. Or we could have done the complement right here. So what's the probability of not A or B? 0.1. So another way we could have gotten this one is 100% minus the one on the outside. We could have gotten 90% that way too. If there are 30 students in Miss Bajan's class, how many are in each part of the Venn diagram? You multiply. So for example, if we take this 0.4 here, we would do 0.4, 40% of 30, and we would get, that's 12 students. We can do 30% of 30, and that's 9 students, and so on. So you multiply the total times the probability to get how many kids are in each part. And so here that would be 12 kids here, 9 here, 6 here, and 10 on the outside. No, not 10 on the outside. Let's change that. That would be 3 on the outside. Let me double check. So we have 30 times 0.1. Yeah, this should be a 3 right here. All right, so that's how we figure out the different probabilities. And how many, again, you would multiply the probability times the number of students to get how many. All right, lastly, we looked at complements, and complements is just the opposite of what they're asking for, so not something. So complement not a certain event. You roll 2 die and add the answers. How can you quickly find the following probabilities? Find the probability the sum is not 8. So you could count all the sums that are not 8 and add them together. But the faster way will be if we do 100% minus the probability of getting an 8. So that'll be much quicker, and that's the complement. So the complement, so again, if we have like this, the complement of A, A faster way to do it is take 100% minus how many are A. So to find the probability that it's not 8, let's count how many 8s there are. So here are the 8s. And there's 5 of them. So if we do 36, which is 100%, minus 5, we will get, well, let's do the probability. Okay, so if we do that, we get 31. All right, so if we do 31 out of 36, that will give us the probability, which is 86.1%. The probability is not 8. Okay, so again, another way that we could have done it is, I'm going to do it down here, 1 minus the probability of getting an 8, which is 31 out of 36. Okay, let's do another one. Find the probability that the sum is greater than or equal to 4. So we're going to count how many are less than 4, and we'll take 1 minus that. So 1 minus less than 4, so let's circle all those. We got 3 out of 36. And so when we're subtracting fractions, it'll be 36 out of 36 minus 3 out of 36. You got a 33 out of 36% chance. If we change that to a decimal, it's 91.6% chance that it's greater than or equal to 4. So the complement is subtracting the opposite of what they want to get what you want. All right, so your assignment's mainly review today. You have set notation, complements, and probability.